Good day, viewers, my amiable viewers. You are welcome back to my channel. My name still remains Israel. In today's video, we are going to have a look at an experiment in practical chemistry, actually salt analysis. And the example we are going to use is already on the board. You see, sample C is a simple salt. Carry out the following analysis on it. To sample C, add water and stir. Test with litmus paper. Divide into 3 portions. To the first portion, add sodium hydroxide aqueous in drops and then in excess. To the second portion, add ammonia aqueous in drops and then in excess. To the third portion, add barium chloride aqueous followed by dilute HCl. To carry out any practical work under salt analysis in chemistry, you must have to draw a table. Putting down readings without drawing a table ends the candidate 0, because there's always a pattern for taking readings. And again, you must not forget to use your aqueous. Any result you write without putting under the test, without including aqueous in the test where it's necessary, means you are testing on solid. The examination body, when they are marking it, they always put TOS, test on solid. In which case, all discussed in that column is 0. So let's start. To do it, you draw a table first. Test. Observation. Inference, or at times you can call it result. So the first one says to sample C, add water and stir. Say sample C plus water, stir. Let's carry it out and see how it's done. This is our sample C. You can see these are sample C. Add water and stir. Add water. Make sure the water is not too much so that you can be able to stir it. You can see it is stirring properly. I do not usually encourage you to put your hand to cover it, because I believe as your hand has sweat pores, through which sweat comes out, and if you don't clean it on time, it tries to diffuse back. If you use your hand to cover it, possibility of it going into your skin is there. Sorry when the solution is not too right, it's not too good. So you see it has dissolved. Then we write our result. Always put in your result as it comes in. Sample C plus water. Say sample C or salt C dissolve in water. You must indicate the color to give a blue solution. Under inference, say soluble salt is present. Or sample C contains a soluble salt. It's a conclusion. Then you go to the next one. It says test with litmus paper. To test with litmus paper, make sure you always use the 2 papers. You can see this one is red litmus paper. We test it first. You see the next red. Let's use the blue. This is blue litmus paper. It has turned it to blue. It has turned it to red, meaning the solution is acidic. You see, solution plus litmus paper. Tones wet, red, blue. Tones wet, blue, litmus. Paper to red. Make sure you use the 2. If you use one, sometimes they don't accept it, but have no effect on wet red litmus paper. So solution is acidic. So this is how you write it. We have already shown in a previous video. Remember, we analyze how you can distinguish between solutions, neutral solutions, acidic solutions, and alkaline solutions. The same thing is what we have just done. The effect on blue litmus paper was that it turns wet blue litmus paper to red, meaning it's acidic because it had no effect on wet red litmus paper. So having done that, continue with the next stage. Said divide into 3 portions. Dividing into 3 portions doesn't mean you have to share it into 3 because the quantity of solution you have differs from the one the other person has. Therefore, all you just need is share into 3. Take 3 portions from it. The smaller the better. 1. And it's always good to always have a reserve in case there is anything, any problem. You're not going to be begging for solution to start afresh. You see it. I still have enough reserve in case there's any casualty. All I need to do is to rinse the test tube and refill. So these are the 3 solutions we are going to work with. Doesn't need to be equal. This is our reserve. So he said to the first portion, add sodium hydroxide in drops and in excess. This is B. First portion plus NaOH aqueous in drops in excess. This sodium hydroxide. Let's see what happens in drops. In drops, you can see blue precipitate, very thick. The thickness stops here. So that is blue precipitate, gelatinous. You see it, it's on top, it's not smooth. So that is in drops, then we can add in excess. No quantity. In excess become thicker. So it's insoluble in excess. You see blue precipitate, gelatinous precipitate. Precipitate is simplified as PPT. In drops, insoluble in essence. Remember, every observation, whatever you observe, must be written. You see, copper suspected, and copper also suspected. You cannot use copper to confirm any. You cannot use sodium hydroxide to confirm this. It's only suspicion. Now, we said to the second portion, add ammonia in drops and then in excess. See, we say second portion plus ammonia in drops in excess. Still underline it. This is our second portion. This is our ammonia. Let's add it in drops. You can see in drops, another blue precipitate, thick. You can see the thickness. Blue precipitate in drops. Let's add in excess. You see it has dissolved in excess. Dissolve in excess to give a deep blue solution. You can see the two. Blue precipitate just like they appear in drops. Now dissolve in excess to give a deep blue solution. Now say blue precipitate in drops dissolves in excess to give a deep blue solution. So in drops, copper 2 is suspected, while in excess, copper 2 is confirmed. Then the last but not the least, we return it back. To the third portion, add barium chloride followed by dilute HCl. That's D. third portion plus barium chloride aqueous plus dilute HCl. Let's see how it goes again. This is the last portion. Remember, these are the two we are having. We still have excess remaining in case of anything. But if at the end of the day, no issue, we discard all of them. So we add the barium chloride. This is our barium chloride. Just watch, it's blue in color. But let's see when we add barium chloride. You see it? It's now whitish. But the color of the blue copper is strong. So it's white precipitate, as you can see. Say followed by dilute HCl. This white precipitate, no effervescent. That rushing gas is not there. Add HCl, you see it, no rushing gas, white precipitate remain. Refuse to leave. So you see third portion plus barium chloride, white precipitate in barium chloride, insoluble in dilute HCl. Here for the white precipitate you have so many ions suspected: SO 4 2 minus, SO 3 2 minus, CO 3 2 minus suspected. In conclusion, because it's insoluble, you have SO4 2 minus present. So that is how it's usually carried out. If it were to be soluble, then it would have been SO3 2 minus. As when you added HCl, you saw vigorous effervescence. Effervescence is mean rushing gas. Just like we did when we were doing tests for carbon dioxide, the way gases were rushing out and were not passing through the delivery tube to the carbon dioxide and started turning milky. Then you suspect tricarbonate 4.